just see where we are time-wise. We've got about another 3 minutes before we kick off. And then as soon as we kick off, we can carry on with those particular concepts. But let's just give it another 3 minutes for anybody else that might need to join so that they can actually join in. I can see, yes, you can hear me fine. Yes, yes, morning to you too. That's absolutely fantastic. So I am definitely coming through nice and loud and clear. All righty. Let's just give it a little bit of time there. Okay. I see we've got more people that are coming in. That's good. Just let that go. I don't need that open anymore. Certainly don't need that open anymore. Alrighty. While we just give it another 2 minutes for everybody to actually get in the meantime, what you guys can do is you can actually use the chat there, and in that chat you can send me some questions that you might have about the AZ900. You can send me messages in terms of where you might think you stuck, things that you might want me to maybe go over with you again, things that you're not really 100% sure of. I know that you guys have been basically doing this as self-study, but this is your time for me to maybe explain certain things that you're not fully understanding. So please, guys and girls, definitely make use of that chat that you have available. All righty. What have we got time-wise? Another minute and then we can kick off.
Good morning, everyone. Morning, Wayne. How are you?
Good and you. Good and you. How you been?
Well, thank you. Well, thank you. So, Wayne, this is our new group of For Africa students. They started at the beginning of the week consuming content. They have received their manuals.
Right.
For those of you who have not received your links yet for your skill pipe or having issues, please, if you haven't mailed me yet, please mail me so that I can sort it out. You will be receiving Azure passes today from us. Yes, and this is Wayne, your trainer. He's going to be going over very important information that you need to know and what he deems relevant. Please feel free to put your hand up and ask questions if you have any, or type it in the comment box. Thanks, Wayne. Thanks everyone.
Thanks, Eloise.
Bye.
Good day. Bye-bye. All right, guys. So as Eloise said, I'm really going to be looking at the content that I want to deliver across to you guys. And I want to start highlighting some very important key areas when it comes to the actual content itself. And I suppose one of the key areas that we need to focus on is going to be, for example, the concepts behind the cloud straight away. I mean, if we look at the cloud, we understand that, yes, it's the next evolution that we're now actually taking in IT, because we started off having to have these physical servers, and we had to have these physical networks and physical storage and teams of people involved in trying to make all of these things work. But this led to a lot of challenges that we started experiencing. I mean, we could look at challenges from a cost perspective. We can look at challenges from a speed to market perspective and so forth. So there were a number of challenges that, you know, we needed to resolve when we were looking at having a physical type of data center. One of the ways in which IT tried to resolve some of these challenges was moving into the next phase of evolution. So you had this on-premise environment. The next phase in the evolution was essentially what we knew as virtualization. So this is where you had products from Microsoft such as Hyper-V that came into play that was aimed at solving some of these on-premise challenges. And we just want to have a look at these challenges in a little bit more detail. And thus, virtualization helped, but it couldn't solve everything. And in some of those cases, it couldn't actually fix the problems correctly. And this is where the next evolution of IT is now upon us. And this is where we now start looking at the cloud. Now, when it comes to concepts behind the cloud, let's just understand one thing first. A big question that some people ask me, they say, Wayne, who owns the cloud, Wayne? Is it actually owned by somebody? And the answer, my dear friends, is no. Nobody actually owns the cloud. You see, the cloud is basically the internet. If you want to think about it like that, the cloud is basically the internet. And we have what we refer to as cloud solution providers like Microsoft Azure that provide us with services in the forms of virtual machines, in the forms of databases, in the forms of storage and networks that we can connect to via the cloud. So basically, we're using the internet to connect to the services that a cloud solution provider is offering us. All right, guys, just again, if you don't have anything to say, then just keep those microphones muted so that we don't end up with too many distractions that can take place. Now, I'm actually going to get onto this one. I'm actually going to give this one a skip. Let's actually do this rather. And I'm going to quickly go to my downloads, and I'm going to go to there. And I'm rather going to use this PowerPoint slide. And let's actually have a look at some of these core concepts that we need to get through. First of all, when it comes to the cloud, now we understand it is the new evolution that we've taken in IT, and we do know that it is going to be solving some of our challenges. Now, the challenges are important for us. The challenges are important for us to understand on this course because, you know, when we had an on-premise type of environment, with an on-premise environment, we had physical equipment. And with physical equipment, we bought it. We had to pay up front for that physical equipment, right? So when we're paying up front for something, it means we have to have CapEx. We have to have capital expenditure available for us to be able to purchase this equipment. So straight away, your first challenge that you have when it comes to an on-premise environment is going to be costs. Now, with virtualization, where we ended up with things like Hyper-V and so forth, did that actually help solve that? Did it help us solve some of these cost problems that we would have? I'm going to go maybe here. And the reason why I'm going to be saying maybe is because it helped us reduce the amount of physical servers needed, but we still needed a physical environment. So yet there was still going to be a cost involved with that. All right. So cost is definitely a big thing when it comes to the actual challenges. The next challenge you're going to have is business continuity. So from a physical perspective, how do we maintain operations? How do we maintain the running of our actual infrastructure? Now, this is divided into three, okay? It's divided into disaster recovery, it's then got high availability, and then you've got fault tolerance. So let's just have a look at those individually quickly, because it's important for us to understand the differences between the three. So first of all, fault tolerance. The key thing to remember about fault tolerance is that it's component level failover, making sure that if anything happens at a component level within your data center, that you have a failover. So some examples. Well, I've now got a server with one network card in it. If that one network card fails, the whole server's off the network. Whereas if I had to put 2 network cards in that server, I now have 2 options. So if one fails, I still have the other one. I have a fault-tolerant networking solution for my server. And you can extend that out. You can extend that out into connecting to storage, networks, server environments, all sorts of stuff, right? You even get some servers that have fault-tolerant power options where they've got 2 power supplies in. So fault tolerance is all about, at a component level, making sure that we have some level of business continuity. Now, it might sound a little bit like high availability, but high availability is different, because you must remember high availability is at the application level. So now I've got a database server, and that database server is running a particular database for our production environment. And if that database server goes down, I lose my database. That means my applications can't reference the database. My application doesn't work. The website that's relying on the application, the website can't get anything, all because of a failure with the main database. So when we're looking at high availability, we need to now think to ourselves, okay, instead of having 1 database server, maybe we should have 2 database servers. We have a primary and we have a secondary, and then they synchronize between each other. And that way, if the primary goes down, then we have the secondary that can carry on with the workload. So we have a highly available database solution. So fault tolerance components, high availability application. So where does disaster recovery fit in? Disaster recovery, guys and girls, is when we look at a site-wide failure. Now, we're not worried about a component. We're not worried about an application. We're worried about the entire building. We're worried about the site. We're worried about the data center. All right. Now, challenges with a physical environment would be, or an on-premise environment would be cost, because I have to buy 2 of everything, at least a minimum of 2 of everything. Golden rule in IT, ladies and gentlemen, N+1. What is needed plus 1, N+1. But this all comes at a cost, right? So components, I have to double up. Servers, I have to double up. Site-wise, I have to double up. So the cost all of a sudden escalates, but so does the complexity of my environment. All of a sudden, my environment is very complex to manage. I've got systems here, systems there, failover processes in place here, disaster recovery. So now my actual physical data center grows, which means I need more building space, I need more fire prevention, I need more cooling, I need more power, I need more networking. All right. All of this comes at a maintenance challenge, a cost challenge, and an availability business continuity challenge. So you can see on-premise environments, although they worked in the past, were quite difficult. But how about we take it even further? What about if I wanted an environment that could automatically grow according to what my demands are? Let's say I've got a website. That website normally takes 100 people logging in every day. But now all of a sudden we become very popular and there's 200 people that are logging in every day. I would like to have an environment that can automatically grow to accommodate those 200 people. That is known as elasticity. Having an environment that can expand and contract based on what my actual workloads are. All right. Now, some of you might be thinking, hang on, I thought that was scalability. All right. Well, the two are linked. Scaling is the ability to add and remove the resources as and when you need it. Elasticity is automating that process so that it happens in the background. You don't have to get involved. All right. So how is that a challenge on premise? Well, straight away, ladies and gentlemen, you can't have scalability and elasticity with an on-premise environment. Why? Because you have to buy the equipment up front. You have to pay for it up front. It's got to be there. All right. So this means, what happens if I don't need it anymore? Well, you spent the money, you still own it, whether you use it or not. The cost is involved, the maintenance is involved, the complexity is involved. You don't have scalability, you don't have elasticity. Global reach, agility, latency, these also become concerns, because if I wanted to expand my environment into Europe or into America or something like that, I need to have a physical premise. I need to be there. I need to have buildings. I need to have equipment. I need to have staff. I need to have all of this. And this means that I can't just allow people in America to connect to my South African environment because I've got latency issues. So global reach is a problem. Latency could be a problem if I want to become a global enterprise. Agility is a problem because I can't just deploy in the UK because I like it. All right. So these are definitely challenges that you have in the physical environments that the cloud is aimed at actually solving. All right. And it's important for us to know the challenges, and it's important for us to know how the cloud resolves it, because these become selling points, but they also become points that we have to manage and implement when we start migrating into the cloud itself. All right. So another important thing about the cloud, all right, is that you would have heard that there's different types of clouds, right? Let me just go back up here. You might have heard that there's different types of clouds. So you would have heard about them saying that there's a public cloud, that there's a private cloud, and that there's a hybrid cloud. It's very easy to understand these, all right? Private cloud straight away isn't a cloud. It's your on-premise physical data center that you have in your building, your equipment that you're managing. It's your own on-premise environment, all right? It's private because you own it. It's private because only your staff can access it. That's why they call it private, right? Public cloud means that I'm using the publicly available internet to be able to connect to my services that are being supplied to me by a cloud solutions provider in order for me to manage my IT infrastructure. All right. It's the public cloud. Public doesn't mean that everybody can access it. Only you can access what you deploy. The cloud is very secure. In fact, it can be secure, if not even more secure, than what a physical on-premise environment could be. All right. But the fact is that it's publicly accessible. Anybody can rent services from this particular cloud, and it's made available via Microsoft Azure, and you use the internet or the cloud to connect to it. All right. The hybrid is really just you having the best of both worlds. That's all you're doing. You're kind of now saying, well, I've got an on-premise environment that I'm already using, but I'm also making use of the public cloud. We see this very often happen when we have companies that have an on-premise physical infrastructure, yet they're using the likes of Office 365 from Microsoft Azure. Or if they've decided to move their dev environment into the cloud, or if they've decided to extend their on-premise network into the cloud, or when they're using cloud as their backup solution. There's many different reasons why people want to use them both. And in this instance, you then end up with a hybrid cloud type of solution. All right. Now, when we start looking at the concepts, we also get introduced to concepts such as infrastructure as a service, platform as a service, software as a service. And I understand, I really do, that if I have to look at these, I'm going pay-as-you-go, IT infrastructure, renting servers, okay, platform provides testing, deployment, software, okay, software as a service. It could all seem a little bit, difficult. It can seem like it's quite a lot to absorb, quite a lot to actually take in. But look at this. Let me open up my good friend Painter so that I can explain these services more effectively. Now, first of all, when you are looking at a environment, any environment, I'm talking about on-premise, I'm talking about virtualized. I'm talking about in the cloud, wherever you are in your stage of evolution. The fact remains that in order for any applications to work that you require in your organization, you need a base. You need a base, you need compute power, you need memory, you need processors, you need storage, you need networking, you need physical servers or virtual machines or some, you need a base for all of this to work, right? And this base is what we call infrastructure as a service. That's what it is. Now, infrastructure as a service comprises of all of your infrastructure requirements. Like I said, whether it be physical or whether it be virtual machines, it's comprising of your CPU, your memory, your storage, your networking, and so forth, all right? So you definitely always require this infrastructure component, whether it's being supplied because you bought it physically, whether you bought a virtualized environment that you're running, or whether you're now renting this particular set of infrastructure resources from Azure, is really up to you, all right? But the thing is, they are definitely required. Now, I have heard a nasty rumor, and I'm just going to quail this rumor now quickly. The nasty rumor that I've heard is that people will turn around and they'll say, oh, you know what, Wayne, I don't like this cloud nonsense because you know what? It's costing people their jobs. And that, ladies and gentlemen, is not true. In fact, the cloud could be creating IT jobs, not destroying them. Where did this rumor start coming in? It's because people were saying, you know what, Wayne, you know, I'm a network guy. You know, I deal with the networks, but now that people are just deploying networks in the cloud, I feel like I'm no longer actually needed, all right? You can't think like that. IT is evolving. Therefore, you have to evolve with it. You used to be skilled and certified on how to deal with networks physically. Then when virtualization came in, Hyper-V and virtual switches and all of this type of stuff, you had to write Hyper-V exams. You had to get those certifications so you can manage your virtual infrastructure. So why would the cloud be different? The cloud still has networking. The cloud still has storage. These gurus just need to certify in the cloud track, and therefore they can keep their jobs and they can carry on working with it. If you decide not to evolve, you only have yourself to blame, all right? So administrators are still going to be needed at this infrastructure as a service layer. It's still going to be there. But it's not good enough just having infrastructure as a service, all right? Because that's just supplying me with my infrastructure. It's like I buy a laptop from Incredible Connection. What have I got? I've got my infrastructure. It's got my CPU, it's got everything. My laptop is my infrastructure, but I need a platform that can run on top of that infrastructure. What do you mean by platform? Well, we need an operating system, don't we? What operating system platform am I wanting to use? Windows, Linux, Solaris, whatever it is. The fact is, you have to choose that platform. If I'm going to be running a database in the environment, then what database platform am I wanting to use? Is it Oracle? Is it Microsoft SQL? Is it MariaDB or Postgres, for example? If I'm going to be a developer, then what development platform am I going to be using? Am I using Python, Ruby, Java, C++, whatever it is? So as you can imagine, just like we have platform as a service, what sits on top of the infrastructure, just like we have infrastructure as a service, what sits on top of the infrastructure is your platform as a service, all right? And that's going to be my operating systems, my databases. Oh, geez, today, bases. It's going to be my dev kits and so forth. And guess what? We're still going to need our database administrators. We're still going to need our developers at this particular level, so to speak, right? So that's what they refer to when they talk about platform as a service. Now, I don't want you guys getting confused, because you're going to hear a lot of other services out there, all right? People try to sound a little bit more intelligent than they really are, right? So these people are now going to be going, well, I work in machine learning as a service, or I work in database as a service. Nonsense. They all fit in underneath the platform as a service layer. Any of these other as a services, you know, dishwasher as a service, Minecraft as a service, whatever. They all fit into one of these three basic cloud concept services. All right. Now, the final one, as you can imagine, is quite simply software as a service. So now I've got my laptop, I've installed Windows, and now I've got Outlook. All right. So now Outlook is my email program. It's my software. It's my application, my software as a service layer that is going to be sitting here. So this is your applications. For example, Office 365 falls beautifully into this layer. And who works here is going to be your users, ladies and gentlemen. All right. So when we go back to our cute little PowerPoint slides here, when they start looking at these as a services, you can quite simply see exactly what they're talking about now. Infrastructure is my servers, my storage, my networking, my firewalls, my physical data centers, whatever. Then platform means I have my operating systems, my databases, my developments. And then software is now going to be my hosted applications themselves. All right. So these were some very, very important areas that we needed to identify when it comes to the actual basic cloud concepts. So if you want to review cloud concepts, what do you really want to look at? You want to look at the benefits, because the benefits of cloud highlight what the challenges were in your physical environment. Secondly, you want to understand the different types of cloud. And then thirdly, you want to understand those three fundamental services. Those are key areas when it comes to understanding the concepts behind the cloud. Now, understanding the concepts puts you in better stead going forward to understand the services, because now we understand the cloud is there, the concepts. We now can understand that these are services that we can rent. These are selling points that we can use to sell the cloud to our customers. These could be selling points that we can use to sell to our own organization so that we can start our cloud migration strategy, sometimes also referred to as your cloud adoption strategy. All right. Now, finally, on the cloud concepts, before I start answering a couple of questions on this particular topic, is serverless computing is something that is now starting to be mentioned a lot. All right. And serverless computing, sometimes people are going, well, it's a way in which we can run our applications, but without the need for infrastructure, without the need for having an actual server with an operating system and all that. In other words, they think that we're canceling out the infrastructure as a service layer and maybe sometimes the platform as a service layer by just being able to upload our actual programming code into Azure, and Azure mysteriously just runs our applications in this serverless environment. You've got to be a bit careful when it comes to that, because it doesn't work that way. Although serverless computing allows us to use things like Azure functions and logic apps where we can upload our code and Azure can then run the code as and when we need it, the fact is, although we're not supplying the infrastructure and the platform, Azure is. Just that Azure is doing it in the background. So serverless computing still requires infrastructure compute and it still requires platform, just that we no longer deal with it. Azure is taking care of that for us. We can just concentrate on our code. We can just concentrate on our actual applications. All right. So that is the core concepts behind the actual cloud itself. Now, these diagrams that I might be drawing up, ladies and gentlemen, don't worry. I am going to be handing them over to Eloise, and Eloise can then always make them available to you guys as well. But let's quickly just have a look at some of the questions. Let's have some questions here quickly with regards to this. What do we have? Anybody have any questions on the concepts? We have a question. Will you share the PowerPoints with us? Eloise is going to have all of that content that she is going to be able to give to you. All right, including any diagrams that I draw or whatever, that will be handed on over to Eloise, and she can make those things available to you. I see that we've got another one. Just the word networking. Okay. I'm assuming that means that you might be struggling a little bit on the networking side of things. Now, lucky for us, networking is actually a core service. So I do have a lot of things that I want to talk about with you guys when it comes to those core services themselves. So hopefully I address everything from a networking standpoint, but if not, then you can always feel free to ask any more questions. I do realize you guys are self-studying. All right, so we do have a question. What is the difference between the Azure Functions and Azure Logic Apps? Well, we do get into it a little bit later when we talk about additional solutions, but just as a nice one here, Azure Functions is what they know as an event-based architecture. And that means that you now log into Azure and you create an Azure function by supplying Azure with your code for whatever it needs, whatever it is that you require that function to perform. All right. Now, if that sounds a bit confusing, maybe this will help you. If you now have a website and your website is responsible for hosting video content in a channel that users can create, and then other people anywhere in the world can access this website and they can stream this video content and they can watch whatever it is. So in other words, you're talking kind of like a YouTube type of environment, if you want to think about it like that, right? The problem is you've got users that are recording with their phone, an old camcorder, webcams, whatever. So there's different resolutions, different formats, different sizes of these particular videos that users are uploading onto the website as part of their channel. Now, you've got a person like me sitting on the other end. I want to watch this person's video, but he's recorded on his phone, and his phone is capable of doing 4K resolution. But I don't have the bandwidth. I don't have the data available for me to be now streaming a 4K video and all that type of stuff. So if I'm going to be hosting that site, then I would like to do something known as media transcoding. And media transcoding means that it can take the raw video that somebody uploads and it can transcode that video into about 10 or 11 different identical videos, but of different resolutions, different sizes, different formats, so that when I log in and I decide I want to stream that video, then I can stream it at 360p on my cell phone or my laptop or in my Mac platform or my Windows platform or my Linux platform or whatever the case may be. Now, media transcoding is just code. So I have the ability to upload that code to Azure Functions. And then when somebody actually uploads a video onto my website, Azure Functions can retrieve that video, run the code, and then spit out the results for my website to be able to use. So that's what function apps are. It's the actual code that runs, based on a particular event. Logic apps is the actual orchestration and the workflow of these serverless types of applications. All right, I hope that makes some sense there. Which one is more beneficial, serverless computing or software as a service? Really, it comes down to the application, all right, because not all applications have been written as a serverless architecture. Now, serverless could be, Azure Functions, yes. But serverless can also be a containerized environment where we have containers, Docker containers, and Kubernetes, and all of these type of things that come into play as well. These are also prime examples of a serverless architecture, but the application needs to be written in a way that it can support serverless. This is where you start hearing about terms like microservices and things like that. Whereas a normal application is normally what they refer to as a monolithic application. It has to be installed on an operating system. The operating system has to have dedicated hardware and so forth. All right. So it comes down to the application and how it's written. Although I can tell you, serverless is now starting to become more and more and more popular because it's easier to scale. It's easier to make more highly available. It's more cost efficient and it's more performance optimized. All right. So a lot of companies are actually starting to move more into that particular space. All right. Is there anything like community cloud? You do kind of get proprietary cloud providers, all right? An example would be the likes of Oracle, IBM, Alibaba. They all have cloud infrastructures, but they're not public cloud providers. Huawei is another one, for example. So they don't really turn around and say that anybody can make use of it. It's proprietary to their brand. It's proprietary to their environment. So in that sense, I suppose you could think about them as community-led clouding, but it's not really the same. All right. Please, what's the major difference between virtual machines and containers? Well, with virtual machines, if you think about it, you now deploy a virtual machine, right? And if you're deploying a virtual machine, you have to choose how much memory is it going to have? How many processors is it going to have? How many network cards? What storage is it going to use? Then you have to choose what operating system you want to run in that virtual machine and so forth, right? Whereas if you look at a container is literally just that, like a shipping container. It doesn't have an operating system. It doesn't have any infrastructure. There's no engine to it, all right? And all that does is it stores your microservices that make up your actual application itself. Now, you're probably wondering, well, then how does that work? How does it work if it doesn't have an operating system and it doesn't have any infrastructure components? A container. Yes, sorry. Was that a question? No? Okay. Whereas a container, if you look at it, it's just like a shipping container. It gets placed onto a ship and the ship transports it wherever it needs to go. When it gets to a destination, a big crane lifts it up and puts it onto another ship, and then that ship takes it somewhere else. So containers in IT are the same type of thing. They have the application, but they are very portable. They can be moved from one type of physical host, virtual host, cloud host, or whatever to another. They can sit on any type of platform and actually work because they hook onto the operating system and the infrastructure of the host that they've landed on. And if you don't want them there anymore, you can pick them up and you can place them here, there, wherever it is you want to actually place it. So they kind of just piggyback on whatever host you put them on, but they don't own their own. There's no dedicated infrastructure or OS assigned to the container itself. So that's the difference between those, really. All right. Please explain serverless computing again. Like I mentioned, whether you're using serverless computing or whether you're using Azure Functions, for example, it's all about the ability for you to run your application without you having to actually dedicate a compute resource, infrastructure resource, and platform in terms of like an operating system or whatever. You're actually handing that over to Azure. So as you want to run the container, or as you want to run the function app, whatever infrastructure is required, Azure will supply. And then when it no longer needs it, it'll take that infrastructure away. You no longer manage that infrastructure component, Azure does. And this means that you're free to concentrate on the application itself, making it a serverless maintainable type of architecture. All right. Can you say Azure is similar to AWS? Well, 100% correct there, Kevin. I mean, and it's not just AWS. There's Google Web Services as well, for example. They're all trying to achieve the same thing. They're all public cloud solution providers that are providing you with physical infrastructure, okay, that they've bought, that they've paid for, that they've got out there, so that you don't have to buy your own. You're just renting some space, some infrastructure, some platform from them in order to run your particular environment. So Azure, AWS, Google, they all do exactly the same thing, just in their own particular type of way. All right. What is the difference between Kubernetes and containers? Well, containers holds the application. Kubernetes deals with automatically orchestrating of the workflow between the different containers. So it's not running the actual applications themselves, that's the container. It's just orchestrating the workflow of information between the actual containers. So that's the difference between containers and Kubernetes. What does nesting mean? They say resource groups can't be nested. Nesting means that you kind of running, let's say, for example, I decide to deploy a virtual machine, all right? And I deploy this big virtual machine in Microsoft Azure, right? And then I go into the virtual machine and I log in, whether it be like a remote desktop connection or whatever. I then connect into the actual virtual machine. And then within the virtual machine, what I do is I install Hyper-V and I create another virtual machine. So I've got a virtual machine that's running within a virtual machine that I've deployed. So I've got a nested virtual machine environment. Another example could be the likes of, in Active Directory, you can have organizational units. So you can have an organizational unit for Joburg, and in that organizational unit, you can have another organizational unit for production, one for dev. So you're nesting your organizational units. All right. Okie dokie. So obviously what they mean in terms of resource groups is that you can't have a resource group within a resource group. Resource groups can only be created at one level is what they're referring to. All right. Could you kindly explain to me why consuming Azure database is considered PaaS and not infrastructure? Well, the database itself, remember, is the platform. It's not the infrastructure. The infrastructure is compute. The infrastructure is memory, network, storage, you know, that sort of thing. What type of database you decide to choose is the platform. It's the platform that the application is going to use. The same as it's a platform that the application be installed into, like an operating system, so to speak. So it's choosing the actual platform, the type of database that you would want to use. All right. Nesting means putting a resource group inside another resource group. 100% correct, which you can't do in Azure. All right. How does this connect together? Microservices, Docker, Kubernetes. Okay, so if you're looking at, let me see if I've got something here quickly. Hold on a sec. It might not necessarily be an Azure drawing, I don't know if I will have it as an Azure drawing. Let's just see. No. Maybe I've got it here. This could work. This could work. So what we can see here is that if I was to look at the way applications can be written, they can be written in a monolithic way. And monolithic means that it requires to be installed in an actual operating system. That operating system would then have to be installed on some type of infrastructure. And the application itself is bundled together. You can't upgrade just a particular component without affecting the entire application. You can't add a new feature without upgrading the entire application. You can't troubleshoot just a particular service without messing with the entire application. Whereas if you break that application up into microservices, all right, then the application as microservices, you can troubleshoot just a particular service. You can scale just a particular service. You can add in another service. All of this frees up that application and the level of complexity, making it easier for you to manage particular components and so forth. But because it's now seen as microservices, it now requires a different way in which it's going to run. And this means that instead of it being installed in an operating system on dedicated infrastructure, we can just place those microservices into a container. The container will then have these OS hooks or operating system hooks that wherever we place the container, it just hooks onto that host and goes, I'm using your OS, I'm using your infrastructure. Whoa, I'm being lifted up. And then it gets placed onto another host, whether it's physical, virtual, it doesn't matter. And it goes, whoop, I'm hooking onto you. I'm now using your operating system. I'm using your infrastructure. And when you're dealing with a multi-containerized type of environment where you have more than one container that is making up your overall solution, then you need effective communications between these containers. You need a way in which you can orchestrate the workflow of data, the workflow of your application between the actual containers. But you also don't want to manually have to deal with it. You want it to be an automated workflow process, orchestrated process. And that is where Kubernetes actually comes into play. It orchestrates the communications, the workflow between the containers and the microservices, as well as allowing for it to be automated. All right. So that's what that means. And I will have Eloise send that out to you then as well. All right. I hope that little illustration helps you a little bit. What is the major difference between SQL database and Azure Cosmos? Well, when you're dealing with databases, you need to remember that you do have relational databases and you have non-relational databases. Now, this all comes down to how is the data actually stored? Is the data needing to be stored in a fixed schema, in rows and columns, in these beautiful little tables, kind of like an Excel spreadsheet sort of thing, all right? Or is the data just going to be dynamically thrown into the likes of a notepad, for example, so that it can be referenced and changed and done whatever it is that needs to happen to it as and when we need to facilitate that? So Microsoft SQL is an example of a relational database where fixed data gets stored in a fixed schema and is managed in a fixed way. Whereas Cosmo is a non-relational database that stores dynamic data in documents, and this data can fluctuate, it can change, it can, many different things can happen with it. I'll give you a prime example of how both of them can work together, actually. For example, guys, if you're not going to be asking a question, please mute your microphones. All right, if you're not asking a question, please mute your microphones. All right. So an example of where they can both be used is, imagine you now go to the website Takealot because now you want to buy coat hangers or socks or whatever it is that you want to buy, right? Now, when you hop onto Takealot, there's a whole list of products. Those products need to be stored somewhere. Those products need to be able to be queried, right? So the product database is actually a relational database. It has all of the products listed in beautiful little cute little tables and rows and columns and all sorts of stuff taking place there. It's fixed data, it's stored permanently, it's fine in a fixed schema. However, you've got a shopping cart. This shopping cart, you're adding stuff to, you're taking stuff away, there's user session data, you're adding multiple quantities, you're changing colors, you're removing this, you're adding payment details, you're adding another card, there's discounts. That's an example of a non-relational database managing your user session data and your shopping cart. And that's where you can see both of them at play there. Alrighty. Are Azure blobs, disks, and files infrastructure or PaaS? That would fall under infrastructure as a service. All right. Remember, blobs is an example of object level storage. Disks is an example of block level storage, and files is an example of shared storage. And in all of those particular instances, they are providing you with the storage needed by your application or your files. And therefore, that makes it part of infrastructure as a service. All right. Earlier, you had mentioned that cloud security is in fact as highly secure, if not more secure. Can you elaborate more on the security aspect of cloud? How exactly is security of cloud with regards to authentication and firewalls to protect your data? Does cloud propose additional features or added benefits besides installing general antivirus software? Well, let's think about this, right? With an on-premise type of environment from a security standpoint, I now have to make sure, now I've got on-premise, I've got physical servers, right? Those physical servers need to be in a server room. That server room needs to have security controls, right? That server room needs to be in a secure building. That secure building needs to be on a secure property. So now, just from a physical access perspective, I need to make sure that I've got 3 or 4 different levels of protection to protect my service from physical access. That's just physical access, right? Now, if physical access is sorted out, I also need to prevent networking access, right? So networking access means I have to have dedicated users. Those users are given permissions. This is all form part of identity management, whether it be Cloud Active Directory or whatever, where users can be authenticated and then they can be authorized in terms of what it is they're actually allowed to manage. So now you need directory services in place. You need to make sure that security-wise, you've got it tied down to exactly who can do what. So role-based access controls, really. You don't want a database administrator being able to log onto Active Directory, for example. So you need to manage all of those permissions. And the bigger your IT department gets, the more complex they can actually get, right? Now, once you've done that, you also need to now worry about intrusion detection. So now you're thinking to yourself, okay, so I need firewalls in place. Those firewalls need rules, inbound and outbound rules, so that we can filter traffic. It's not just good enough for me to have a perimeter-based firewall. I also need to have firewalling at the interface level of my actual servers as well, so that I can have double down firewall networking security. Not many companies implement that in a physical on-premise environment. They just let the perimeter-based firewall do its work and they hope their normal security measures are in place. But let's say you've got all your firewalling done and your firewalling's in place and your networking's done, switches, as well as everything else. Now you need to worry about attacks, not just intrusion, but attacks. Attacks in the form of virus attacks, in the form of injections, in the form of distributed denial of service attacks, all right? Once you've now got third-party software installed that you license, that you're paying for to manage all of that, Now you also need to worry about encryption, encryption of data at rest, encryption of data in transit, and so forth, all right? Now, all of this is your baby to manage. But if you now deal with the cloud, physical security is no longer your issue. That's now Microsoft's issue. The capacity is no longer your issue. That's Microsoft's issue. High availability, fault tolerance, recovery. Microsoft need to supply that physically for you. You don't have to deal with that anymore. So what do you have to deal with? Well, you need to deal with access, so identity and access management, that you can now also choose to enable multi-factor authentication as part of that as well. You need to worry about things like distributed denial of service attacks. Well, lucky for you, Azure already has it included by default. It's not something that you have to actually additionally pay for. It's already there. You have to worry about the likes of encryption. Well, they give you encryption of data at rest, encryption of data in transit, but they also give you the ability for you to store company secrets. They also give you the ability to make use of their certificate services. They give you perimeter-based firewalls. They give you interface-based firewalls. They basically give you a level of protection at all of the different layers, giving you a full defense in-depth strategy, all right, that you normally can't get, or if you really want it, is going to be quite complex and costly to implement in an on-premise type of environment. So you can secure the cloud, if not the same, also a little bit better than what you can actually deal with in a physical type of environment. All right. Azure Kubernetes is responsible for VM cluster management. Can you please explain what exactly is VM cluster management? Well, as I mentioned, what you need to understand for this is that Kubernetes is an open source architecture. When they say open source architecture, it means that it can work across any platform, Linux, Windows. It can work across any type of infrastructure, physical, virtual, clouded, whatever it is, in order to maintain the workflow of communications between your containerized environment. That's really what you need to consider right now when it comes to Kubernetes. Now, Kubernetes in terms of scaling is going to be helpful. But when it comes to virtual machine cluster management, now, Kubernetes deals with containers. It's not responsible for uptime management of virtual machines, all right? That's a totally different ballgame. If you're talking about cluster management in terms of your containerized environment, it works in conjunction with the likes of your container registry, maintaining the uptime and availability of your actual applications themselves. All right. Thanks for breaking this down. How does this connect together, microservices, Docker? But you haven't really explained how Docker comes in. Right, so with Docker, my apologies. With Docker, let's just go back to this, all right? Oh, wait, not that one. All right, well, you can remember where that was. Docker is basically, they refer to it as the Docker engine, and Docker sits inside a container. Now, we understand what a container is. We understand what the microservices are, and we understand what the hooks are. But still, you need something in the container that can talk back to the container registry, that can talk back to container cluster management, that can talk to the likes of Kubernetes. You need some component in the container, kind of like they refer to it as a Docker engine, but I mean, you know, you need some kind of component there that can work with the microservices, work with the contents in the container, work with the additional solutions like the container registry, Docker hubs, Kubernetes, and so forth. So that's where Docker comes in, and it sits in every single container to allow for management of that container. All right. Is Docker like an API? I suppose, you know, you can think about it like an API because you can make use of it like an API. All right. Yeah, in a way you can think about it that way. All right. Any other questions, guys and girls? questions that came through there. Any other questions? How does express routes work? Okay, when it comes to express routes, imagine how you're normally connecting to Azure. You're normally connecting to Azure via the internet, right? So you're on your laptop, you connect to Wi-Fi, you open up the Azure portal, bang, you connected, all that type of stuff, right? But what happens if you've now got an on-premise environment that has an application, and that application needs to actually talk to another application in the cloud? This means you're now going to be relying on these two applications communicating with each other via the internet. So what is going to affect this application? The reliability of the internet, the performance of the internet, the speed of the internet, and whether the internet is actually even there or available. I mean, you disconnect from Wi-Fi, bang, it's gone. You know what I'm saying? So these could be potential problems that you can have. And this could also affect the performance of the application. So express routes is now removing that internet-based type of option and giving you a dedicated route, an express route. You know, it used to be back in the old days, if I wanted to get from my house in Florida to Sun City, man, there was like 3 different routes and it would take 3.5 hours for me to get there, so to speak. That's kind of like the internet. Whereas they then built, many years ago, they then built a simple road that can take you straight through to Sun City. Cuts down my time by about 45, 50 minutes, and it's a lot bigger, more traffic can be handled, performance is easier. It's similar to that. I now have a dedicated route that I can actually take to connect me to my actual Azure environment. So that's really what it is. It's a dedicated connection between you and your network within Azure. All right. Any other questions, guys, before we move on to those core services? You all good? All right, fantastic. All right, so let's now quickly have a look here. We're now going to quickly hop onto our core services here. All right, and when you're looking at Azure, you must understand that there are core services and then there's additional solutions. All right, core services are services that we use all the time in Azure. They are fundamental to any type of environment that we want to use, all right? Whereas additional services are things that we can use if our company actually requires them. Like, does our company use Internet of Things? Does our company require machine learning, all right? Does our company rely on serverless computing, or is it quite happy just using virtual machines, right? Whereas if we look at the core services now, let me just get to here, are really about, oh man, come on, Wayne. Why is it not coming through? I wanted to get to, there we are. Core services are all about virtual machines, networks, storage, and databases. So it's just those 4 key areas that we need to look at in terms of the core services. Now, the stuff that I might have looked like I've skipped up at the top, this is all part of your self-learning process. And this is really just how is Azure actually deployed within the environment? How is Azure deployed as such? Now, when we look at Azure's deployment, just quickly, I know it is self-study, but just quickly, Azure is deployed all of the physical infrastructure that any company would normally need, all right, into regions that are scattered all over the globe. So you can imagine, instead of me now having to buy physical servers and guessing how much capacity I need and so forth, Azure has now deployed all of this physical infrastructure all over the world, and I can just rent services from them. It means that I don't have to pay that upfront cost. It means that I don't have to worry about physical security. It means I don't have to worry about the heavy maintenance costs of maintaining a physical infrastructure. Happy days. But how does Azure guarantee that I will have access to these physical resources? And how does Azure guarantee that I can have high availability and disaster recovery? Well, you see, Azure took the globe, right? So we have the world, we got this globe, and they realized that the globe is kind of made up of multiple geographies, really, all right? Geographies like, for example, Africa is a geography, North America is a geography, South America is a geography, Australia is a geography, Europe's a geography, and so forth, right? And they thought in these geographies, it might be beneficial for us to now deploy regions, all right? And in these regions, we're going to deploy multiple physical data centers with physical infrastructure that our customers can rent, all right? So when they do that, first of all, why would they have multiple data centers in a region? Well, they want to give you fault tolerance, all right? This means fault tolerance is there by default, and we don't have to pay for it because it's a Microsoft thing. Microsoft have to make sure that their data centers are fault tolerant, all right? So they give us multiple data centers so that we can deploy our solutions that can take advantage of fault tolerance. They also include high availability zones, whereby they will have zone 1 and zone 2 in a region, and these regions will have 2 data centers each, and I can deploy my applications across those availability zones. So now, if something happens with the data center, if something happens with both data centers, if something happens with the availability zone, the fact is my application will still run. So I have fault tolerance and I have high availability. But they don't just put one region in a geography. There will always be a minimum of 2 regions per geography, known as region pairs. Like Africa, for example, it's got 2 regions. We've got Johannesburg North, we've got Johannesburg South, right? And Cape Town South. And this means, or Cape Town West as they call it. And this means that not only can I have my solutions deployed in Johannesburg North, but if I need to, I can replicate that to Cape Town West, so that if something happens to the Johannesburg North region, I have disaster recovery already built in there, so that I can now make use of that secondary region. All right. So architecturally, they deployed their physical infrastructure in a fault-tolerant, highly available disaster recovery manner that we can now make use of via the use of over 60+ regions scattered all over the globe on all of these geographies. But it also has another benefit. Remember that global reach and that agility that I was talking about? Well, now, if I want to expand out into the UK, there's already a UK region. So I can very easily just deploy my services in the UK region and I'm done within minutes. I don't need that premise. I don't need that upfront cost. I don't need that headache of additional maintenance and staff and physical equipment and all of that type of stuff. All right. Is express route over the public internet or not? No, the express route is not over the public internet. It's a dedicated connection between yourself and express route partner that is a direct partner with AWS, all right? And from the direct partner or the express partner, that'll go straight into the Azure environment. Sorry, not AWS, into the Azure environment, all right? So it's not going over the internet, it's a dedicated connection. Why do we have availability zones? Why can't all regions be available? Well, the availability zones, not all regions have availability zones at the moment. So, you know, Microsoft Azure are still in the process of making more availability zones available. But if you're looking at having the regions available, region failover is disaster recovery. So, you know, that could now lead to additional types of worries about the application itself. Whereas, you know, when you're looking at availability zones, you're having immediate availability of the application in the event of a failure within the same actual region. All right. Why do we have only one availability zone in Africa? That's currently because they are still being deployed. So it's not that they aren't going to, it's just that it's an ongoing process. So as they deploy regions, they then fine tune the regions by adding additional availability zones. So they're still in the process of making that available to us. All right, but they did want us to have the ability to use Azure in the meantime. All right. Okay. So now, understanding the architecture, what is important for us to now remember and realize about the core services? First of all, when it comes to compute, we have a compute category, all right? And when they refer to compute, what they're saying about compute is that compute is supplying us with the compute resources needed for our applications to run. Examples of compute resources would be memory, storage, networking, processing, all right? Now, we have different ways in which we can get that compute. We can have dedicated virtual machines that we now need to pay for, all right? Whether we are using all of those virtual machines or not, we still have to pay for them while they're running. This means that part of a cost savings initiative is that if you're not using a virtual machine, turn it off. Because while it's running, you're paying for it, whether you're using it or not. If you're not using it, turn it off. You'll save money that way. Otherwise, these compute resources could be supplied to the application through the use of the likes of app services, being those function type applications, containerized instances, and so forth. So the compute category means that we have various different compute services, like virtual machine services, app services, container services, or whatever, that our applications can use in order to gain compute power, infrastructure power for the application itself. All right. Virtual networks is all about creating a networking environment that my cloud services can make use of. The same way that in a physical on-premise environment, you require networking. Physical switches, physical routers or routers, if you want to be American, with root paths and firewalls and all sorts of stuff. Well, if you need that on-premise physically, you're clearly going to need that in a clouded environment as well. But the beauty is you have the ability to join the two. You can actually join your on-premise network to your clouded network. How? Via express routes, all right, those dedicated connections. Or if you want to go via the internet, then you can have a virtual private network gateway or VPN gateway. Otherwise, you can quite simply just build out your own clouded network infrastructure for your clouded services using virtual networking. All right, and that's where the virtual network side actually comes in. Now, in many organizations, you know, you have different types of storage. So you might have object level storage. Now, object level storage just means it's a container. That's all it is. It's like me walking around with a big container, putting in all of these children's toys that I've got, all right? It's a place where I can store my kids' toys. It's a container for storing them. It's a box, all right? Those kids' toys are just objects. They're not dynamically changed or anything. They're static objects. They're there, they're stored there. When I need them, I can take them out, I can hand them over. When I'm finished, I can put them back again. That's it. Object level storage is for storing static files that never change so that they can be made available to websites, users, whatever the case may be. All right. Block level storage, however, is a bit different. Block level storage is your actual virtual disks. If you want to think about block storage in the physical sense, it's your physical hard drives or your external USB drives or whatever it is. It's storage that is storing files that are dynamic in nature. I can delete them, I can change them, I can add things to them, I can save them, I can do whatever I like with them, all right? It's dynamic that I've got. And that type of data gets stored on block level storage, which is exactly what your normal hard drives are. And in the clouded space, that's what virtual disks are, all right? Then you get file shares. And file shares is literally a single place where multiple sources can look at information. It's shared storage. So I might have 12 different virtual machines. They all need to access the same files. Therefore, I can place those files onto shared storage. Now, bearing in mind that we have the different types of storage, it's obvious that Azure is going to make that type of storage available to us. So with blob storage, we can create these containers where we can upload these files or objects that we can now store in these containers for whatever purpose, static objects, objects that never change. However, we can also create virtual disks that we can attach to virtual machines that can be used for block level storage. And we can use file shares as a way of creating shared storage that we can actually make use of. Now, if we come to the database side of things, clearly we need to remember that in the real world environments, there's multiple different database types. Not only is there relational databases and non-relational databases, but there's different database engines like Postgres SQL, MySQL, MariaDB SQL, Microsoft SQL, for example, all right? These are different database engines that work with relational databases, all right? So Microsoft Azure gives you the opportunity to be able to deploy these databases so that you can actually make use of them. Now, the important key takeaway on this particular side of things, right, is to remember that with databases, you've got two ways in which you can manage databases in Azure. One, create a virtual machine, have it running Microsoft Windows, remote desktop into it, install the database yourself, Microsoft SQL yourself. But that means it's a self-managed database. You have to take care of patches, you have to take care of scaling, you have to take care of high availability, you have to take care of all of that. Or you can make use of Azure's database services, which means you just deploy a database. All the infrastructure and all of the platform requirements are now taken care of by Azure. You are free to focus on what matters, which is the actual database itself. This is a managed service from Azure. And this means that availability, backup, scaling, all that type of stuff is no longer your headache. It's the responsibility of Azure to maintain that. All right. Now, all of these services, all of these core services, whether it's compute, whether it's networking, storage, or whatever, we can deploy these ourselves. Or why reinvent the wheel? Let's be honest. There might be people out there, and I've had this before loads of times. Ladies and gentlemen, I'm telling you, the amount of times people have actually got a hold of me and they've said to me, Wayne, they're trying to install WordPress in a virtual machine because now they want to actually use WordPress for hosting their website within a virtual machine. Now they've got the virtual machine deployed, they've got the operating system, they're licensing the actual OS. It's Windows Server 2019, Wayne. And I'm thinking this is great, but you could have just gone to Azure Marketplace, typed in WordPress, and either WordPress themselves or somebody else would have already created a virtual machine with WordPress installed, with it already configured with whatever it is that you want to do. So why reinvent the wheel? Just go to the marketplace. That one looks like exactly what I want. You click it, you bring it in, you customize it, you go away, and then everything starts working. You can do this with Citrix deployments, Kaspersky deployments, SAP HANA deployments, whatever it is that you want to do. WordPress, as I mentioned, right? I've even had people, and I'm not joking, I've even had people turn around and say, Wayne, they want to deploy a Minecraft server. So there's Minecraft servers available in the marketplace, believe it or not, for gaming. People have said to me they don't want to pay ExpressVPN or Teddy Bear VPN or whatever. So you can deploy your own open VPN server in Azure if you wanted to. All right. So why reinvent the wheel? These things are already there. All right. So from a compute, just remember we have virtual machines, we have app services and those functional apps. We have container instances with their Kubernetes counterpart that can provide my applications with the necessary infrastructure that they require in order for them to be able to run. All right. In terms of Windows virtual desktops, this just allows you to create a cloud-based virtual desktop infrastructure that your users can use instead of you having to have localized physical desktops on everybody's desk as well. All right. So we have the virtual machine side of things, 100%. In terms of app services as well as the function apps just allows you to basically deploy your applications, upload your code, and make it available to Azure so that you can use it as and when you require. All of the platform, all of the infrastructure is basically taken care of by Azure itself, and it does support coding in the various different forms, whether it be .NET, Python, Java, PHP, whatever it is that you normally use. All right. Containerized environments, I think we understand now exactly what container instances are and what Kubernetes are, so that's pretty good. And we understand the virtual desktop infrastructure now as well. Now, in terms of networking, just remember, we can build out our own cloud network by deploying our virtual network within Microsoft Azure for our Azure hosted services. We can also have our own physical on-premise network and join the two together. Sometimes they call this extending your physical on-premise network into the cloud through the use of either express routes as dedicated connections or via VPN type of environments. Storage-wise, just remember the different types of storage: object, block, and file shares, and the fact that Azure Storage Services allows you to support the different types of storage that your environment might actually require. All right. And in terms of databases, remember, there's relational, there's non-relational. So Cosmo database, non-relational database service, otherwise relational database services that can be self-managed by me deploying a virtual machine and deploying either Microsoft SQL or whatever it is, or I can use database services and managed service from Azure, and I can deploy a relational database using either the SQL engine, the MySQL engine, or the Postgres SQL engine itself.
Sorry, Wayne.
Yes, go for it.
This networking thing is kind of fuzzy to me, you know, like the VPN gateway and also the internet key exchanges and site to site, point to point, all that stuff is still kind of fuzzy to me. Can you dive in a bit deeper on that?
I can a little bit. Obviously, I can't go too in depth, but let's just have a look at something here, right? Now, I use this for AWS, but it does. Do I have a networking one here? No, I don't. Okay. I'm just going to quickly hop onto my AWS drawings here, just to kind of give you a bit of a networking view, right? Now, this is AWS, but within Azure, it kind of works very similar, all right? in the sense where, from a networking perspective, you're now deploying virtual machines, you're deploying containers, you're deploying databases as such and whatever. And these components need to be able to communicate with each other, all right? Now, in the physical networking environments, what did we have? Well, we had routers. And what does a router do? It routes the traffic between your different environments. That's its job, or router if you want to be American, right? So then we have switches. Now, what does a switch do? Well, you see, the switch maintains your actual RP network. And an RP network is created through the use of managing RP addresses, all right? These are sometimes known as your CIDR block address ranges, or CIDR, but I'm not going to get into too much detail about that. So in a normal organization, a physical on-premise environment, your network guru is going to have these switches, and he's decided that your organization is going to use the network range for private RP addresses of 192.168.0.0 or 10.1.0.0 or 172. Whatever. The fact is, he's now got this private RP address range that he now wants to make use of. So now I hop onto Azure, and in Azure I say, you know what? In the Johannesburg region, I want to create a virtual network. And when I create this virtual network, I'm giving this virtual network a private RP address range, 10.0.0.0, which means I'm now going to have 65,536 private RP addresses for anything that I'm deploying on that network, right? But that's not how it normally works in the real world, you see, because in the real world, you might have a production network, a development network, a quality assurance network, storage network, a management network, could be floor 1, floor 2, floor 3, floor 4 type of network. And we're dividing these guys up into different VLANs in the physical type of environment, or subnets, subnetworks, all right? Now, each one of these subnetworks or subnets will have a portion of those RP addresses taken from the overall RP address range that they can then use to give any virtual machines or resources that we deploy that are going to be on that specific network. So in this particular example, I've got a public network because I have web services that need to be publicly available, and I've got a private subnet for my database servers and this and that, the next thing. And you'll notice in green here that what I've done is I've given them a portion of the overall RP address range to use as RP addresses that they can give out just to components that I've got on that subnetwork. Right? So you create the virtual network with the overall RP address screen. You create the little subnets with portions of that RP address range that they can use. And then you deploy your virtual machines, your databases, your containerized environments, whatever it is, into these subnets, and then they can be given a private RP address that they can use. But remember, once you've got that in place, you've got your routes, your router with your routing tables, that's going to be routing traffic to your different networks, but you also need to be able to protect the data. And this is where your firewalls will come in. So as your firewall would come in here, as your perimeter-based network, it sits before the data even gets into your virtual network so that you can filter traffic based on port protocol IP address for inbound and outbound connections. All right. Now, once that's done, remember, you're going to have these virtual machines or whatever it is sitting in that network. So you want to make sure that each virtual machine has its own little firewall that we can actually use as well. And this is known as your network security groups in Azure. And these are interface-based firewalls that, yet again, we can now manage and filter the traffic based on port protocol, IP address, or inbound and outbound connections to the specific server itself. All right? And thus now what we're doing is we've created a network with subnets. We've deployed our virtual machines, we've got our routes, and we've got our firewalls in place. And now everything is working swimmingly. But if we're in a region that has multiple availability zones, there's nothing to say that we can't duplicate what we've got in one availability zone into the second availability zone, because then that gives me the ability to throw a load balancer in between them. So that traffic can now be load balanced between the different instances we have in the different subnets in my different availability zones, thus creating a highly tolerant, highly available, highly performance optimized application delivery solution. All right. Now, obviously,
what's the need of having a balancer?
What's that? Sorry?
So what's the need of having a load balancer? Isn't the other region acting kind of like a redundant region?
It will. You can do it that way, but remember, if you do it that way, then there's the time it takes for failover. So it's the time it takes for it to actually do a health check to determine that that region has actually failed, for example, before it will then start rerouting to the failover region. Whereas if you implement a load balancer between AZs, then the load balancing is immediate. The failover is immediate. Does that make sense?
Yeah, it does. Thank you.
No problem. Now, in Azure, this is where you'll have your corporate network, and you can have your Azure network. And what you'll notice is that you can have an express route connection, which will connect you directly from your corporate network to your Azure environment, or you can go via a VPN gateway, which uses the internet to actually extend your networking into the Azure cloud. You can also use a combination of both. The VPN connection could be the failover connection for your express route, for example. Did that diagram help? I know that it was actually for AWS, but it's very similar.
Yeah, it did.
Fantastic. I'll draw one out and I'll give it to Eloise, and she can make it available to you for Azure as well. It's just so that you've got all the key terms and stuff like that. All right. So let's have a look at some questions that we're now going to have there, ladies and gentlemen. And if we look, it says, can I explain more about network gateway, containers, and Kubernetes? Well, the network gateways are essentially the gateways for you to be able to extend your on-premise environment into the actual cloud. So you can start making use of these virtual private network gateways or VPN gateways to facilitate that. But your express routes will also utilize that gateway anyway, because that's now your dedicated type of connection. Just going up a little bit. Okay. Please, what is the difference between Azure SQL databases, MySQL, and okay, there's no difference between those. They're all relational databases. It's just that these are different engines. So it's the same as if I've got a BMW, a Merc, or a Beetle. The fact is, all three of them are cars, but they just come from different manufacturers with different engines. They all do the same thing, but in their own different way. All right. So they're all examples of relational databases, but just with their own engine, essentially. All right. Can't explain more about, yeah, I've done that. Could you also tackle big data, Azure Synapses? I'm going to be doing that just now as we move on into the next actual PowerPoint presentation. All right. What are subnets? Subnets, like I said, they sub-networks of your overall network, right? So imagine I've got a house. My house is my main environment that I live in, right? But me and my kids all have our own individual rooms. So we have rooms in the actual house. And these rooms pertain to different environments, like it's my environment in my room. My son has his environment in his room. So networks are the same. when you build out your networking through the use of a switch, then you're building the house with the overall IP address scheme, and then you're creating these subnets in that network for the various different environments and giving them a portion of IP addresses that they can give out to the individual services that are on there. All right. Could you expand more on 10.0.1.0 and 10.0.0.1? Okay, so if you look at, let me come back to that. Let me bring this up quickly. The first thing to identify networking is that you do have an overall IP address range, right? It's a block address range known as a side address range block. In this instance, it's 10.0.0.0/16. Now that /16 is the subnet mask, all right? And this is a class B network. And this means that the subnet mask is going to be 255.255.0.0, all right? Now, when we look at the IP addressing convention, then if I've got 10.0.0.0 with a subnet mask of 255.255.0.0, the first 255 is for the 10. The second 255 is for the 0. And that means that that is my network portion of my IP address. So my actual network for my entire switching environment is 10.0. And this means that anything after that, anything from 0.0 upwards, belongs to any device that is going to be on the 10.0 network. So this could be 10.0.0.1 all the way up until 10.0.0.254. After that, it'll be 10.0.1.1 and 10.0.1.2 all the way up until 10.0.1.254. And then it could be 10.0.2.1. And this means that if I carry on, if I had to add that, if I had to times them together, it means that I can have a total of 65,536 private IP addresses given out to devices on my 10.0 network. Right? Now, when I'm creating these additional rooms in the house, when I'm creating these additional subnets, all right, I'm saying that I've got a subnet for my production servers, right? So I want them to be completely separated from my development servers, and I want them to be separated from my QA servers, because those are different environments, the same as my room and my son's room are different environments in the house, all right? So therefore, all production servers need to have their own private IP address in the production subnet. So what I do is I take a portion of that overall IP block address range, all right, and I create a new network range just for my subnet. Now, what you'll notice is that 10.0 is still there, all right, because it belongs to the actual network. But what I've done here is I've got 10.0.1.0/24. This means that my subnet mask is actually 255.255.255.0, which means the new network just for my subnet is 10.0.1. All right, so 10.0.1 is the production environment's private IP address range that falls part of my overall networking environment. And I can now have 10.0.1.1 up until 10.0.1.254. So I can have a total of 251 private devices in my production subnet. All right. And you can see that we've done that for the various different subnets. So 10.0.2 is a completely different network to 10.0.1. All right. So anything that I put in here is going to get an IP address that's going to start with 10.0.2, not 10.0.1, because those are two different environments. Yet they all fall under the overall IP address range. All right. So I hope that explains it a little bit better for you. All right. So the subnet can further be branched out. Of course it can, yes. However, the networking can become quite a complex beast if you're not too careful. This is why it's definitely beneficial for somebody who's going to be dealing with this to obviously be network orientated, because they're going to need to be building this out. They're going to need to be building out the routes. They're going to need to be, building out your actual firewalling and prevention and stuff like that from a networking perspective. And this is why I say clouding doesn't cost jobs. It's a network guy's job to actually evolve and get himself certified in the new way things actually work. All right. So I hope that does actually explain it a little bit better and make it a little bit easier for you guys to understand. All right.
Sorry, so concerning the firewall,
yes.
So there's the overall firewall security, and then there can still be the ones between, say, subnets, right?
Yes, 100% correct. In fact, there's 3 layers of firewall if you want to think about it. So Azure firewall is the name of the firewall that is at the perimeter level. So it's your first line of defense. It's your first port of call where all inbound traffic is going to get to. All right. So at that level, you can now filter out traffic based on port, protocol, or IP address, based on what type of traffic is going to be generally accepted into your network. Then what you can do is you can use network security groups. Now, network security groups attach to the interface of your virtual machines. All right, so they're not at the subnet level, they're actually at the interface level, the actual virtual network card layer of your virtual machines, where you can now filter traffic that is coming into the virtual machine before it gets to the virtual machine based on port, protocol, IP address, inbound, outbound. The third layer is the one that we're all kind of used to already, is because when you go into the operating system, like if it's a Windows Server operating system, at the OS level, there's an application level firewall as well that you can deal with there. Now with clouding actually takes it a step further. Because of serverless computing and stuff like that, they give you other types of firewalls as well. They give you storage level firewalling, they give you web application firewalls as well as a front door for direct access to applications and such. So this is why I say you can actually add more security with a clouded type of environment compared to what you can do with a physical environment. All right. Does that make sense?
Yeah, it does. It's pretty cool stuff.
Perfect. Awesome stuff. All right. So now let's quickly have a look at the third topic. And the third topic that they wanted us to cover here was going to be the additional solutions as such. Now, additional solutions is essentially, solutions for a particular organization if they require that solution, because not all corporates require machine learning. Not all corporates require Internet of Things. However, we have found that these tend to be the ones that are the most commonly used, and that's why they refer to them as core solutions. All right, but not every company does actually make use of them. And those core solutions that they refer to, number one, Internet of Things. Now, Internet of Things is management of your internet capable devices. And a prime example of this would be the likes of smart homes. You guys can go to Builders Warehouse, for example. You can go to the smart home section and you can buy a light switch that connects to your Wi-Fi. And as if by magic, you've got an application on your phone and you can turn on or off your light switch. You can schedule it to turn on at 4 in the morning and turn off at 6 o'clock in the evening and all sorts of things. You can set it to dim to a certain particular level. And if you've got a color changing bulb, you can set it to change colors and all sorts of nonsense, all right? This is an example of Internet of Things devices. Now, companies like Sonos, for example, they've already created all these Internet of Things type of devices for smart homes and stuff, right? And they've now already made their devices available via a cloud solution, so that when you download the application, when you turn off your light switch, essentially the application sends a message to the cloud that is being managed by Sonos, and that message is then received by your Internet of Things hub, all right? And that Internet of Things hub then delivers the message to the correct device to turn off your light switch. But how do you manage all of your Internet of Things assets is where the IoT Central actually comes from. And if you want to build out a proper orchestrated solution for all of these Internet of Things assets, that's where Azure vSphere comes in. So if you are an organization that develops Internet of Things based devices or solutions, then you can make use of IoT Hub for your messaging, IoT Central for the registering and managing of your devices, and Azure vSphere for the orchestration of those devices. Now, another very popular, very popular solution is data analysis and data warehousing. All right, and this is where Azure Synapse Analytics, HD Insight, and Azure Databricks actually comes in. These are services that Azure provides to an organization for effective data analysis, data warehousing, data transforming of raw data that you might be receiving within your organization. Examples of this could be the likes of share prices. So you can imagine if I'm a company that is dealing with shares and the stock market, and I have a website, and that website has a ticky tape of share prices, up-to-date information as it happens, my business is receiving all of this raw data from a particular source, all right, whatever your source is. So all of this raw data is coming in, but that raw data needs to be analyzed, it needs to be transformed, it needs to be displayed correctly, all right? And then that data needs to be stored as well, but that's going to be vast amounts of data, lots of data. So therefore, data warehousing comes into play for storage of bulk amounts of data. And that is where Synapse's HD Insight Databrick actually comes into it. Now, another type of solution is going to be machine learning cognitive services, which you can just remember as artificial intelligence, all right? And then Azure bot services. Now, for machine learning, believe it or not, you use machine learning every day. Any one of you that are on this session right now that has ever been to YouTube, has got Netflix or Prime or Hulu or Disney Plus or HBO, whatever it is, believe it or not, you're using machine learning. And why do I say that? It's because if I go to YouTube and I look up egg recipes in YouTube, right? And I now then watch 5 videos on how to cook eggs in 5 different ways. Guess what? I end up with a recommended watching list. And what's going to be in that recommended list? A whole bunch of egg videos. If I'm on Netflix and I've watched my 3rd action movie in a row, recommended for me is going to be some new action movies. So it's learning from past data how it can more finely tune the experience for me. And that is what machine learning does. Machine learning is a solution that can learn from past data on how to finely tune the application itself or the results or whatever it is that you want from it in order to give you better delivery of your application. So that's just an example of where machine learning comes in. Cognitive services is artificial intelligence. It's your solution now making informed decisions on what it should do based on what it sees, what it hears, what it reads, whatever the case may be. and it's then going to make an informed decision based on, obviously previous logic or whatever that we've got in there. An example of this could be self-driving cars. An example of this is our military drones, for example. These are systems that make an informed decision based on information that it's collected from what it's able to see, what it's able to hear, that sort of thing. All right. Now, Azure bot services is becoming more and more commonly used in certain applications that we already use. Those of you that might use Discord, or those of you that might use Telegram, for example. We are ending up with these bot services that when we connect, we now just tell the bot service a couple of key bits of information, and then it scurries off and it finds everything that I wanted to find. It's a service that I can give it some key information and it can fill in applications for me. It's a service that I can give it some key information and it can join particular networks for me. So it's just a service that is waiting for me to input the correct data so that it can perform whatever job function it is that we want it to do. Now, serverless computing, we've already covered that quite a lot, because now we know from a serverless computing perspective, we've got containers, we've got Kubernetes, we've got functions, and we've got logic apps. So thanks to a lot of the questions that we've already had, we now understand a lot more about those serverless computing components.
Okay.
But there is a difference though. There is a difference between serverless computing with containers and serverless computing with function apps. All right. With containers, we have the microservices, it's there, it's running, it's making use of what an infrastructure and platform it is, or based on the host that it's on, we're happy days. Functions apps is code that is waiting for an event to occur. It's an event-based architecture. So like I was giving the example of my streaming media website, that function app, that code that I've uploaded for media transcoding or for data analysis, for example, is just sitting there. It's doing nothing until such time as a user uploads a video or some raw data has been received. Then what happens is an event gets sent to the function app that says, hey, there's a new video, or hey, there's some new data. And as soon as it receives that event, it then runs the code that it's meant to, spits out the result that it's meant to, and then it stops again, waiting for the new event. But in all cases, I'm not dedicating any virtual machines, I'm not dedicating any operating systems, because Azure will take care of that as and when it requires it for the container, for the function app, or whatever the case may be. Now, if you are going to be moving into the development space, all right, and you want to start developing solutions within Azure, then Azure do give you a full development solution, a development platform that you can use for developing, testing, expanding, bug fixing, whatever of any solutions it is that you actually want to deploy. And they even give you a full dev test lab environment that you can use to streamline your applications in a beta type of environment before moving into a public access alpha phase of your particular solution. So they do have a full DevOps side of things as well. So just yes, go for it.
Okay, okay, you change your slide. Okay, I wanted to ask the Azure bot services. I know you said we need to feed it some data. So, but where does it get the other data used to?
Well, it depends on you, really. It depends on you. I mean, it can receive that data from a number of different sources. It could be manual input. It could be automatically received from whatever other type of service, maybe from an analytics service, maybe from a function app, maybe from a website where a user is capturing stuff in the website, for example. So, where it receives the data is essentially up to you. And then what it does is also essentially whatever you tell it you want it to do. Does that make sense?
Yes, thank you very much. And also the last one,
Yeah.
the Internet of Things hub. Is there a way you can just only use the Internet of Things hub without trying to use the Internet of Things Central and the other one?
Yeah, look, I mean, Internet of Things isn't there for you to now maybe plug your phone into or something. It's if you're an organization that is in, let's say, for example, you manufacturing Internet of Things capable devices. Like I said, for example, I gave the example of home automation. And the reason why I use home automation is because it's becoming more and more popular, really, at the end of the day. So if you are a company that is, responsible for that, or is in that particular line of business, then Internet of Things now becomes your way forward, whereby you can manage and asset track your Internet of Things devices through the likes of using Central. You don't have to use Central, but I mean, how else are you going to be able to monitor, affect different types of connectivity, or allow for scale management of your Internet of Things resources? But when you've got multiple Internet of Things devices and communication is a must between them, then you are going to need the IoT hub, because that deals with the unidirectional as well as bidirectional communication between your multiple devices that you have within your environment. And then obviously, yes, there is obviously going to be the likes of Azure vSphere, where you can use that for building out your communication platform, orchestrating that particular platform, adding in additional security features, that sort of thing. Does that answer your question? Are you happy with that?
Yeah, it does. Thank you.
No problem, 100%. All right, so Internet of Things, it's important for us just to understand what it is, because once we understand what it is, we can then see how those different things actually fit in. Big data and analytics was where we're now looking at the transforming of raw data through the use of analysis and whatever, for our particular environments. And then that can comprise, or move along with the likes of your data warehousing for storing of large data, that sort of stuff. Your machine learning, your cognitive services or artificial intelligence, and your bot services. Just remember that these are things that are already out there, they're already in use. And if you're an organization that wants to start developing on that, then you can, 100%. We also now know about the serverless computing environment. We're happy with the different types of solutions for serverless computing and how they all fit in. It's just very important for us to remember the distinction between serverless computing from a containerized environment and serverless computing from a Azure Functions based. Remember, it's event-based code when you're using Azure Functions. All right. And then you do have that development platform available as well. All right. Now, how do you manage your Azure environment? Now, in order for us to really identify with this, I'm going to go to this particular diagram here. And when it comes to managing of your Azure environment, right? Your Azure environment, you have many different tools available that you can use to manage it. There is the website. You can go to azure.microsoft.com and you can log into the Azure portal and you can use that web interface to manage your Azure environment. If you want to manage it via your mobile phone, there's a mobile app that you can use, or a tablet. If you are a person that's command line driven, then there's PowerShell and there's a command line interface tool and so forth. There's many different tools available for us to manage our Azure environments, all right? But whatever tool you're using, all right, it's going to be connecting to the main Azure component, the component that is responsible for not only managing all of our resources, but also for managing our authentication and authorization, and that is known as Azure Resource Manager, or ARM. So regardless of what tool we're using, we use the tool of our choice to connect to ARM, Azure Resource Manager, and it's from ARM that we then deploy our resources, manage our security, deal with our networks, handle authentication, and so forth. All right. But there are the various different tools available. Now, also, we need to remember that Azure has also made their APIs available. So you'll often find that sometimes a third-party vendor might have written his own application, or maybe you've got an application that requires talking to a particular service, and you can utilize the Azure APIs there to build out your own type of management tool if need be. All right. Now, this, and finally for this module, is one of the biggest things that I recommend everybody does once they've deployed an Azure environment. Because how do you know you deployed the environment correctly? How do you know that the virtual machine you deployed is secure? How do you know that it's optimized at the best performance level? How do you know that you deployed it in a manner which means that you can reduce the costs needed? So a lot of people now go through the website, they start looking at white papers, they Googling stuff, and that's all fine and dandy. It's great for the learning curve. But Azure's already got you covered. Azure already has a tool there called the Azure Advisor in Azure, regardless of what method you're using, that you can actually use to determine if your environment is deployed correctly. It's a tool that's going to look and it's going to say, right, well, you've now deployed this solution. Is it reliable enough according to Azure best practices? Is it secure enough according to best practices? Is it running at the performance level that it could? Is it cost optimized? So Azure Advisor looks at all of the best practices, runs that against your solution, and then gives you recommendations on how you can fine-tune your environment. So you then just fine-tune it according to those recommendations, and you'll have an environment that is cost-efficient, performance optimized, highly reliable, and very secure. Kind of takes a lot of the guesswork away from you. So Advisor, regardless of how much you think you know Azure or how much experience you've got, the most experienced Azure architect will always come back to Advisor just in case. And that's something I recommend that you guys definitely have a look at. And that is the end of that particular module in terms of what it is we really just needed to cover as an importance. So coming back to our questions here, what type of service is Google Translate? Well, Google Translate essentially runs under Google Web. So that well, it depends on how they would have it implemented, really. I'm not too sure how they would have it implemented in Google Web. But if it was me, I would probably just run that as the likes of an Azure function, for example, whereby it looks at one database of terminology and collects and queries the second database. Happy day. So you can use like serverless computing function. In fact, that would probably be the most cost-effective way to do it, because if it's a virtual machine, I'm paying for the virtual machine, I'm paying for the license, whereas with a function app, I'm only paying for the time that the actual transaction runs to do that translation. That's it. So it might be a hell of a lot more cost-effective.
Yeah, it makes sense to run it as a function, but I was actually referring to like cognitive services or a bot, since it's like natural language. So do you think maybe it's like a bot,
right.
a cognitive service?
So it's more than likely going to use a bot service to try and determine your location. That way, based on location, it's going to be able to then say, okay, well, you're in, for example, the UK, so clearly your language is English, and then what it can do is through, let's say you copied some Russian text, for example, and you've now pasted it in. From there, it's able to then determine the language type. Okay, so this is now Russian, you're in the UK, so I'm now going to translate from Russian to English, for example. Or if you're in France and it's going to say, I'm going to translate from Russian to French, for example. But in saying that, it could also adopt a certain level of machine learning, because maybe you've done this quite often. Maybe you're constantly translating from Russian into English. So therefore, that would be the default setting that it decides to place. So instead of you having to change it the whole time, it's going to go, well, the last 20 times it's been Russian to English. So your default settings are now going to be Russian to English. So it really depends. It can use a wealth of different services for that, really, at the end of the day. Would you say that machine learning is an advanced method of the internet cookies capability? If not, what's the distinct difference between the two? Well, machine learning can use cookies, if you want to think about it that way. In fact, you might have seen, for example, like if you logged out of a particular website, and then 2 days later you log back in and the website goes, welcome back, Wayne. That's not machine learning, that's your cookies. Your cookies know that you were there before. Now you've logged in again, it goes, welcome back, Wayne, But the machine learning side could be fine-tuning your experience on that particular website. Like, for example, the YouTube giving you a recommended list, that sort of thing. All right. True or false? Internet Information Services environment. The cloud tenant is responsible for routine hardware maintenance. 100% correct. All right. Who is the tenant? Who's the person that owns the actual hardware? The person who owns the hardware is Azure, isn't it? Wouldn't you agree? All right. But that's hardware level. Who's responsible for maybe patches in an operating system in the virtual machine? That might be for you. You must always remember it's a shared responsibility model. So, Azure's responsible for everything that is of the cloud. You're responsible for everything that you put in it. Okay, it's a very good distinction to make. Okay. Why is all the Azure resources not available in all regions? Why are some resource regions based when we have high availability? Right. So when they first release a service in Azure, there's a couple of things that they need to take into consideration. One, they need to look at the rollout of the actual service. So what they'll do is they'll roll out the service to core regions first, like North Virginia, like Ireland, and that sort of thing. So it'll run to the core regions in each geography. And then from there, it'll slowly make its way across to the other regions that it's got. It doesn't mean that a region won't get that service. It just means that it might be taking some time for that service to become available. But then you've also got to remember there's a lot of other things that come into play with services. There could be governmental legislation. There could be standards and compliances. There could be attestations that Microsoft needs to meet before that service can be made available. Data transfer, for example, is different in South Africa than what it is in America. So sometimes, let's say if you want to do acceleration, acceleration might be allowed in the US, but in South Africa, before acceleration is allowed, they might want Microsoft to meet certain standards before that would be allowed. And in that case, that can slow down the deployment of that service in that particular region because they're trying to meet those particular rules and legislations. All right. Kindly explain the ARM templates. ARM templates is, well, basically any resource that you deploy, virtual machine, storage, networking, whatever. When you're clicking through that web interface and you're now setting it up and you're getting ready to deploy, what it does in the background is it actually builds a JSON script, a JavaScript object notational language script in the background. You're not building it, you're just pointy clicky and doing everything else. You could build one if you know JSON, but it builds this script in the background. Now that script, you can save it. All right, if you want to. And if you save that script, that now becomes the template for you to be able to deploy that service exactly the same way over and over and over again. So if I'm now building out a call center in Azure, instead of me deploying 100 virtual machines, manually 1, 2, 3, 4, I can actually build it out once, and then I can deploy it another 99 times via the template, just to automate the deployment of my services and streamline it and make it a lot easier. All right. So that's what they mean by those ARM templates. All right. Any other questions on that, guys and girls, ladies and gentlemen? Could you please explain what cloud tenant means? Well, tenant is where your actual services are going to be running. So you can imagine if they've got a particular region, and in that region they've got these data centers. What is a data center? A data center is a collection of tens of thousands of physical servers and everything else, and networking and storage and whatever, that they've now got in that particular data center. But they've got multiple data centers of fault tolerance. All right. So the cloud tenant is essentially who is hosting your application. Okay, what is actually hosting that application? Which data center, which host, whatever the case may be. All right. So ARM is good for someone who isn't familiar with codes. 100%. Look, I'm not familiar with codes. I'm not familiar with coding at all. I am not a developer. I'm not a script kid either. So I can't build out JSON scripts myself. I've tried, but I'm just absolutely useless with it. So for me, it's a lot easier for me to actually either download a template from the internet, or, you know, once I've deployed a solution, to save the template or export the template. And then I've got it for every time that I want to do that afterwards. In fact, for clients that I have, I've got templates for all of them, so that I don't have to reinvent the wheel if they want me to redeploy something or deploy something again for another type of environment. It just makes my life a hell of a lot easier. All right. What's the main difference between availability zones and availability regions? Well, regions are infrastructure or data center deployments that you have in a particular region. So let's take, for example, North Virginia in America, right? So North Virginia in America is a region, and in that region, they've got 6 physical data centers comprising of tens of thousands of different, or tens of thousands of servers and networking and storage in each individual data center. And they have the multiple data centers, obviously, to facilitate fault tolerance, and also to allow capacity, right? But what they'll do is they'll have 3 of those data centers in availability zone 1, and the other 3 of those data centers in availability zone 2. And these availability zones are separated by hundreds of kilometers from each other within that region, all right? Maybe not hundreds, but I mean, you can imagine, for example, if they were to incorporate that into Johannesburg, you'd probably have an availability zone sitting in Sandton and another availability zone sitting in Pretoria, for example, all right? And they each house their own collection of physical data centers. And this just means that within that region, your application can be deployed in a high availability manner to allow immediate failover in case something happens with any component in one availability zone, whereas regional failover is disaster recovery. So now something has happened with that particular region, we're now failing over our entire environment to the secondary region, which in our case is Cape Town West, as part of the Africa geography. Okay, so let's just finally look at the last one, which is now just going to be our security side. Now, from a security side, I want to use 2 PowerPoint slides for this. The first one here is just to identify some additional features that we have from a security perspective, right? And when we're looking at the additional features that we have, we want to look at the fact that in Azure, we have a security center. Now, what does the security center do? Well, we've got various different security methods and security options. We've got firewalls, we've got distributed denial of service protection, we've got encryption, we've got encryption keys, we've got certificates, we've got key tokens, and all sorts of stuff. So we want a centralized place where we can monitor the security of our deployment. It's like a prison. You know, in these massive prisons, you've got one main center control room that controls the security of your prison. And that's essentially what the security center is. It's where you can do your audits. It's where you can analyze your logs. It's where you can view intrusion detections, right from the detection to the actual closing phase of that particular problem, that threat assessment, that sort of thing. It's where it can give you recommendations after evaluating the security of your particular environment. You've got Sentinel, which is your security guard with a truncheon that is walking around your cloud deployment, analyzing logs, auditing logs to determine if there's been any breaches in your security, any vulnerabilities that have been taken advantage of. You got the Key Vault for storing your company's secrets in the form of digital certificates, encryption key pairs, that sort of stuff, right? Ultimately, if you really want to try and take security to the highest level that you can have in Azure, but it's going to cost you the big bucks, you can turn around to Azure and you can say that in their data center, you want to own an entire physical dedicated host that nobody else can use. You own it, but that's going to cost you. But then that means you have to take care of all of the security of that dedicated host as well, because you're saying you own it, therefore you must maintain it. So we have a number of different features available to us when it comes to the security of our particular environment. So some key things. Always look at the security center. It's your centralized hub for monitoring of how secure your environment is and looking at your recommendations. All right. Understand that security is a shared responsibility. All right. Because it's Azure that's responsible for the security of the cloud. You're responsible for what you put in the cloud. So they give you your Azure firewall, your network security groups, your routing tables, your encryption of data at rest, encryption of data in transit, your additional firewalling like web application firewalls and so forth. So they give you everything you need. They also give you full identity and access management if need be, which is something we're going to be looking at now. All right. So you do have these tools available to you that you can make use of. Remember, you've got your security guard that's constantly walking around and making sure that everything is still intact and that everything is working. A vault where you can store all your secrets, like the safe you might have in your house, for example. Or you can go for that dedicated host option. But now, one of the fundamental things here is understanding this. Microsoft's defense in-depth strategy. And what they mean by this is that they've taken care of the physical security. That's layer number one. However, you need to make sure that you use all the tools that they supply you to create a level of security at all the different levels getting to your data, thus giving you a full defense in-depth strategy and making it extremely difficult for people to access. So make sure you've got proper identity and access management. Make sure you've got your perimeter firewalls and your network security groups and your web application firewalls and encrypting of your actual data so that you can align yourself with a full defense in-depth strategy. And remember, it is a shared responsibility model. So you're not alone. It's Microsoft Azure responsible for the security of the cloud. You're responsible for what you put in the actual cloud. Now, remember, from a firewalling perspective, Azure firewall, perimeter-based firewall, all right? Network security groups, the firewall that attaches to the virtual network cards of your virtual instances. They both do the same thing. Network security groups just allows you to be a little bit more granular with the actual virtual machine itself, whereas Azure Firewall is perimeter, first port of call. All right. Now, DDoS protection, as I mentioned, is there by default. So you already do have distributed denial of service protection available from Azure. It's free, it's there. It's called DDoS Basic, all right? So you've got it. What is distributed denial of service attacks in the first place, Wayne? What is DDoS, all right? Thank you for telling me it's there in its basic form, but I don't even know what it is, right? Imagine this, right? Imagine you now own a restaurant, right? And your restaurant has got 10 tables available. And any given night, you always have at least maybe one table available. You're ticking over, you're doing very well, it's fantastic, right? Now your competition all of a sudden says, you know what, I need to get rid of this restaurant because now they're starting to encroach on my profits here. So what does he do? Illegally and behind your back, all right, he goes and he has 100,000 flyers made up. And on those flyers, it says a pizza and a Coke for R5. All of a sudden, what happens? You don't just have people occupying your 10 tables. Now, all of a sudden, you've got about 1,000 people lined up outside of your restaurant. You don't have enough staff. You don't have enough tables. You can't give away things at those prices. You don't have enough stock. So what happens? You're overwhelmed. Your business just shuts down. You can't deal with this. And that is exactly what a DDoS attack is in the real world environments. If you've got Gmail and all of a sudden we have 1 billion people trying to authenticate at exactly the same time, Gmail doesn't have enough compute resources to handle that volume. So it underperforms, it starts shutting down, it crashes. All right, so we need protection against that. So luckily, Azure's already got that included in the basic form. However, you can pay for standard DDoS protection. Sounds weird. I thought standard would be the free version, but they call the free version basic. Standard means that you pay a little itsy bitsy extra, and now you can have some additional mitigation options and order tracking and advanced notifications of potential DDoS attacks. But the basic version is there, is for free. Just remember the two ones, basic and standard. All right, standard you pay for, basic is free. And now you also know what a DDoS attack potentially is. So once you've got all that in place and you've got your full defense in-depth strategy working, then congratulations, you have a properly secure environment that you can audit against the security center, and you can use Trusted Advisor to determine, is there any way in which you can improve on your security? But security doesn't just stop there. Remember, with security, it's not just about firewalls and encryption and certificates and all that type of stuff. It also comes down to authentication and authorization. Authentication is authenticating who you are. I am a user. This is my username. This is my password. It checks on Active Directory if it's correct. It is correct. You're authenticated. It's not correct. You haven't been authenticated. But once you're authenticated, what are you authorized to do? What are you allowed to connect to? That's authorization. All right. And that's in the form of permissions. Now with Azure, you need to follow a role-based access control methodology. And that means don't just give everybody admin rights. That's ridiculous, right? Network guys only need access to the network stuff. So therefore, you create them as users, you put them in a network group, and you assign them permissions to only be able to manage the network services. Database guys, virtual machine guys, whatever the case may be. Use your authentication and authorization correctly to create this role-based access control where people only have access to what it is that they're actually allowed to access. This just streamlines things, makes it easier to manage, and so forth. Now, I know what a lot of people might be saying. They're saying, okay, Wayne, but I'm used to that in the sense where, like at work, we got this cute little thing called an Active Directory, and we can create users and we can create groups and then we can assign permissions. Is that the same in Azure? The answer is yes. Azure has its own Active Directory, and that Active Directory can actually be used for single sign-on purposes. It can be used for authentication purposes. It can be used for temporary credentials for temporary staff members, or temporary credentials for an application to access an Azure service, whatever it is. They do have their own Azure Active Directory. But Wayne, we've already got Active Directory on-premise. Can't I just use that one? Well, yes, you can. Of course you can. We allow for Active Directory on-premise to work with Azure. You can merge the two. You can allow for that synchronization. All right. So you can use your on-premise Active Directory if you wanted to. You guys might have experienced this already, where you're logging onto your work environments with your Active Directory usernames and passwords that they give you at work, but all of a sudden it's working with Azure Office 365 in the cloud. And that's because there is AD integration allowed. You can have that working for you within your environments. All right. So many ways to skin cats if you're into skinning cats. Just remember the key things there about the security. Defense in depth strategy, and allow for role-based access control when it comes to your authentication and your authorization. All righty. Now, those were the topics that they wanted me to cover with you guys today, and just basically highlight some key strategic areas that you definitely are going to need to know. And I hope I have actually been able to answer a lot of the questions, but let's just have a look at any additional questions that might have come in. What happens when a client stores his or her resources in a zone and not in a region, and something happens to the zone? Well, you cannot store any resources out of a region. All resources that you create are deployed in an actual region. All right. So you do get certain global services that are not region specific, like Azure DNS and things like that, but those are normally managed by Azure. So whenever you're deploying a network, whenever you're deploying a virtual machine, or whenever you're deploying storage, you will always be asked what region you want to deploy that resource into. All right. True or false, infrastructure environment, the cloud tenant? Yeah, we've answered that one. On this question, if the cloud tenant performs the hardware maintenance, what does the cloud provider do? Well, the cloud provider is the one that's dealing with the hardware maintenance. That's the tenant. You must remember that we can't, as customers, I can't now go to Microsoft's data center, knock on the door and say, look, I'm just coming in because I want to work on one of your physical servers. They won't allow that because it's their equipment. They're the ones hosting the physical infrastructure. They're responsible for the hardware maintenance. All right. You're just responsible for the services that you're running on that hardware. All right. That's what you need to remember. Okay. Is there any way Azure makes sure customers do not use their resources and services for illegitimate or fraudulent activities? Well, therein lies another security aspect of it. All right. If I decide that I want to make use of Azure as my cloud service provider, and then let's say I now upload a document, and inside that document is, I don't know, instructions on how to grow marijuana or whatever the case may be. If Azure suddenly comes to me and says, hey, listen, you've got this document that you've uploaded here with instructions on how to grow marijuana, and that's illegal. My first question is going to be, what are you doing in my environment? Why are you looking at my documents? Surely this is meant to be a secure platform. And as a secure platform, it means it must be secure against you as well. I can't be allowing anybody just to be able to access my documents. I might have sensitive information. I might be a government agency. And I just can't have anybody from Microsoft accessing the documents because I'm a government agency. That's wrong. So as a agreement that Microsoft has to attest to and has to be certified with in terms of government legislation, not even Microsoft can access your data unless you expressly give them permission to. All right. And if you've encrypted any data and you've now lost your encryption key, Microsoft can't access it. All right, because it is secure. That's how secure it is. Not even Microsoft can access your data. All right. Does an organization need to subscribe for different resources it needs, or is there an umbrella subscription? Well, when it comes to subscriptions, you've got many types. So I'll give you an example. If I was to look at myself being a cloud consultant, and I've now got a couple of customers that I deal with. I actually manage their cloud environment. For me to now have a login for each individual one to manage all the environments, I could do that. Or I could just have a root subscription, which is for me, and then I can use organizations or management groups to create these organizational units for the companies that I manage. And then I can have a subscription for each one of them. So you can have multiple subscriptions for the different environments, and you can even highlight who's responsible for paying that particular subscription. And you can have that managed by one overall root account if you wanted to. Or you can just manage each one individually. It's entirely up to you. But you'll find that in large organizations, they might have a root subscription for the organization, and then each department will be paying for their resources out of their own cost center. So those departments will belong to their own management group, and that management group will have its own subscription, and that subscription is then payable by that particular department head. This is also known as sometimes a billing boundary or a resource boundary that you can actually create. All right. Why is VM infrastructure as a service and container platform as a service? Because the container is supplying the platform for your application. Virtual machine is supplying the compute resources. A container can run on a virtual machine, all right? Because remember, the container itself doesn't have its own compute. It doesn't have its own memory, operating system, or anything. So therefore, if I place it on a virtual machine, or if I place it on a physical host or whatever, it's going to hook onto that, utilize that infrastructure as a service to run the platform that the application is requiring. And the platform essentially becomes the container. All right. Multiple subscriptions in one account. Yes, you can have multiple subscriptions in the one account. So it's not a subscription inside a subscription, although I suppose you can think about it that way, nesting subscriptions, if you will, but each subscription can be managed individually. Each subscription can be managed independently from each other because they are responsible just for their set of resources. All right. So you can use them to create a billing boundary as such, as they like to refer to it. All right. Any other questions, ladies and gentlemen, guys and girls? No, you're all good?
Hello, sir, please can you hear me, sir?
Yes, go for it.
Hello, can you hear me, sir?
I can hear you, yes. I can hear you fine. Well, I could hear you fine. I still don't understand subnets. What is it exactly about the subnets that you're getting a bit confused on? Maybe I can help you that way. Remember, all you're doing is you're breaking up your network into smaller little networks at the end of the day. So let's say I own a company called Milk, or Milk Limited. That's my company, and I have my company network. But then within my company, I have different environments, and each environment requires its own specific network, IP address ranges, and whatever. So I basically break up my company network into these multiple different sub-networks, if you will. Maybe that helps a little bit.
Okay. So my question is, when you are creating a resource in Azure, you'll be asked to choose a zone, availability zone. Then my one is, when you see between zone, region, and geographical regions. So my one is, if you choose zone, which is the smallest, and something should happen to the zone, does it mean that your file is being backed up on the region, or it's just like, okay, well, once something happens to the zone, you have lost the file?
You're choosing the zone in the region. So remember, availability zones don't exist on their own. They exist inside regions. So therefore, when it's asking you to choose the zone, it's asking you to choose which availability zone in that region that you would like to actually deploy your services on. All right. Okay, the address 10.0.0.1/24. What does 16 and 24 actually mean? Okay, that's all to do with the subnet. All right, I'll quickly draw something up for you to maybe help you understand that a little bit better. But just before I draw that up, let's just see here. What about bandwidth problem? Is Azure service delivery, will it affect the service usage in some cases? You know, your bandwidth side of things, you must remember that Azure's backbone is a highly high speed, highly available backbone within the Azure environment. Your connectivity into Azure is going to affect how your performance will be. In terms of accessing a particular resource. So if you've got a 10K line or a 1 meg line or a 1 gig line, you can imagine your performance will be different accessing that particular resource. But the resource network bandwidth available in the backbone is still going to be exactly the same. So sometimes you might want to optimize the performance of your bandwidth a little bit by, for example, let's say I'm housing a website in Johannesburg, all right? Now, if I'm housing the website in Johannesburg, for me to connect to it, because I'm more local, is actually not that bad in terms of latency. But somebody who's in the UK might be now trying to access that website, which essentially means they're coming across to the South African region. So therefore, the bandwidth constraints might create a little bit of latency or some performance issues. But you must remember, you have the agility and the global reach that Azure provides. I can deploy that website in the UK region. So not only will I have it in Johannesburg, I can also have it in the UK region, which means that person will then be accessing the website via the UK region instead of coming all the way to Joburg, which will then reduce that latency and optimize your application a little bit. All right. Now, to come back quickly on this question here, not understanding about what the /24s and all of that type of stuff mean. I'm just going to open up Paint here quickly. Oops. There we go, Paint. Now, you must understand that when you're looking at an IP address, all right, let me just come in here. Where is my mouse? My mouse has disappeared. Hello, mouse? I can't see my mouse. Oh, there it is. So when we're looking at an IP address, and let me just make this font just a little bit bigger here. How do I make it bigger? I want to, well, let's do this. And I'm going to make it a bit bigger. Let's make it 24. So, or make it even a bit bigger still. Let's make it 36. So now this is my IP address, 192.168.160, for example, 8.160.9. Let's just say that, right? So what you'll notice is that in an IP address, the IP address is actually broken up into 4 individual segments, all right? And these segments are then separated by these dots, all right? Now, these segments are called octets, okay, in an IP address, all right? And these octets themselves are divided up further into what they call bits, all right? So it's basically 8 bits per octet, all right? So you can have 1, let's just do 2, 3, 4. I'm doing this terribly. Okay, so basically each octet is made up of 8 bits. So I'm just going to go 8 bits here. Type it in, 8 bits. All right, like so. Okay, so now what happens is we understand that the IP address is broken up into 4 octets, and each octet is broken up into 8 bits. Now, if my subnet mask, let's now have a look at a subnet mask. Let's draw one in here. And let's say the subnet mask for this particular IP address is 255.255.255.0. All right. It means that all 8 bits are on. All 8 bits are on. All 8 bits are on. No bits are on. And this means that the network portion of my IP address is now that portion there. 192.255.168.255.160.255. So every single device that I connect to this network, all of them are going to have 192.168.160 as part of their IP address, because that's now their network range. The unique part of the IP address will be the last octet, okay? So there, so in other words, .9 is the unique portion of that IP address. Let me just do this and make it another cute little color just so that we can see like so. Oh, that's a terrible color. Let's make it pink. There we go. Okay. So that's now the unique portion, right? Now, if that means that 8 bits are on over here, 8 bits are on over there, and 8 bits are on over here, if you add them all together, it's 8, 16, 24. That means that this is a /20, oops, a /24 network, which is a Class C network. All right. And this means that I can only have IP addresses from 1 up until 254. So 192.168.160.1 up until 192.168.160.254. So that's how many single devices I can have on that particular network. Now, if, however, I had to now say that the subnet mask was 255.255.0.0, then that means it's only those 2 octets that are responsible for the network. So that's 8, that's 16, and that means that this is now a /16, which means I can have 254 times 254 addresses, which gives me a total of 65,536, oops, 65,536 devices on that particular network. So that's how that /16 and /24 and all of that type of stuff actually works. I hope that answers your question there. I hope it actually makes a lot more sense. Okay, if PowerShell is convenient for developers familiar with Windows and the command line interface for Linux, are there management tools for Ubuntu, macOS, and the rest? Well, Ubuntu is Linux. So essentially, you can be utilizing the command line interface tool, PuTTY, anything that can give you SSH connectivity to that OS if you wanted to go directly onto it or whatever, or serial console connection. It's entirely up to you. Is in the terms of Mac OS, you don't really get Mac OS deployments in Azure within virtual machines. It's basically going to be Windows, and it's going to be Linux as your deployments. All right. Hope that answers your question. Any other questions, guys and girls? How old is Azure? Well, I'm not 100% sure as to how old it is. I know that AWS officially launched in 2006, so 15 years ago. And AWS was the very first public cloud solution provider. Following on from that came Azure, and then came Google, okay, in terms of their deployment. So I think Azure probably around about, it's over 10 years. So it's probably about 12 years or something around about there, but I'm not 100% sure. All right. Please explain what Windows Virtual Desktop means and its usefulness. Well, if you think about it, we've now covered the fact that we can deploy virtual servers for anything that we want in our server infrastructure type of environment. But what happens if I've got 100 users and each one of these users now requires their own desktop? That means a physical desktop, a physical monitor, mouse, keyboard. Then I'm still going to need network connections, which means I'm still going to need a switch and so forth. It also means that I could run into the potential problem where users are saving data on their local desktop. So if the hard drive crashes, I lose that data, or they haven't backed up properly, or this and that, the next thing. So instead, what I can do is, instead of them utilizing their local desktop, I can give them a virtual desktop in Azure that they can connect to, and that they can use. This means that from a central point, I can manage my patch management, version control. I still have all the data regardless of whatever device they're using failing. I can just manage my environment better. And if, let's say, 10 new people start, I can literally deploy those 10 new desktops within minutes instead of having to go to procurement, justify purchase, wait 6 weeks delivery for their new laptops, hand it over to the IT staff, get them to prep the whole thing up and blah, blah, blah. You know, that sort of thing. So it does have a lot of uses, and it can be very useful. All right. Could you switch your screen back to the subnet description? Yes, sure, by all means. If that's what it is that you were looking for. All right. Let's maybe minimize it a little bit, like so, just so I can see any other questions that might come in. All righty. All right, what's the difference between VMs and virtual desktops? Oh, well, there we go. I just explained that in my previous one. So I hope that explanation explained that to you as well. Virtual machines is there for your server type environments. Virtual desktop would be for your users' desktops. All right. Any other questions for me, ladies and gentlemen, before we start off? What time do we have here?
Mr. Martin.
Oh, yeah, we're 15 minutes over, but that's okay for now. Yes.
If the virtual desktop still runs on a physical desktop, what is the essence of it? Is it only for just file management?
If the virtual desktop is running in a?
It's still going to run on a physical desktop.
So that depends. I mean, you know, you can access that virtual desktop in many different ways. I mean, yes, you could have a laptop, you can have a physical desktop and all that type of stuff that can be used to access the virtual desktop. Then a lot of people are going to say, yeah, but if I've got the virtual desktop or if I've got a physical desktop or a physical laptop, why do I need the virtual ones then? It will be just purely because it will be able to simplify your management of those desktops, patches, version control, licensing, all that type of stuff. But you're not restricted to only being able to use laptops or physical desktops to access the virtual one. You can access it from a tablet, you can access it from your phone, you can access it from a thin client or a dumb terminal, for example. So, you know, it's that sort of thing. All right. Azure have any container offering? Yeah, you can actually deploy container instances through Azure, as well as work with Kubernetes within Azure as well. All right. Containerized instances. Yes, in the marketplace, there are already containerized solutions that you can have a look at in the marketplace as well. Oh. Any other questions, guys? We are 15 minutes over, but I apologize for keeping you for that 15 minutes, but we've had some really, really good questions. But with that being said, then, guys and girls, if we're all done, I hope this has really been of a benefit. I hope I explained things a little bit easier for you guys than just actually reading what you might have had in a textbook. How is Azure better than AWS or Oracle Cloud Services? Oracle Cloud Services is proprietary, so it's for the Oracle environment. So that doesn't really come into it as far as Azure and AWS. In terms of which is better, they both do the same thing. So it really comes down to your particular preference. There is no right or wrong provider. It really comes down to testing which one's going to be better for you. You'll find that most companies that have a cloud adoption strategy are actually running tests on both platforms to determine which one is actually going to do the job better. And then once they've actually done their proof of concept, they choose the provider that they would prefer to go with. All right. All right, ladies and gentlemen, thanks very much for joining me. As I mentioned, I hope this has been very beneficial to you guys. I hope you guys have learned a lot. There is still going to be some more sessions. I'm sure that Eloise will fill you in at a later stage. So yes, good luck with your journey. Good luck with your learning process. Good luck with those exams. I'm really, really rooting for you guys. Have a great rest of your day and have a great weekend going forward. But for now, thanks very much, guys. We can all log off now, and I'll see you guys again soon. Thank you, thank you. Thank you. It's a pleasure getting nice thanks messages. It's always but a pleasure, always but a pleasure. Thank you, thanks. My pleasure. I'm loving it. You guys have been absolutely fantastic, and thank you for all the questions. Love answering questions. All right. Thanks, guys. I'm actually going to close off now, but thanks very much. Bye-bye. Keep well.